Continue on with question 6. Okay. You are given this color of line spectrum with a respective wavelength. Okay, you need to know that this red, green, and blue is visible light, okay, which is the color of rainbow. Okay, so this color would be in Balmer series with a ground state of n equal to 2. So A, calculate the energy emitted for the formation of red line and green line. The question said the energy is emitted, means released. So you need to write or include negative sign at your final answer. So let's try red line. Okay, so we are asked to find the energy for red and green line. Okay, so class, which formula that you want to use? Okay, you will only be given information about the wavelength or lambda. Okay, so let's check. So can we use this formula? No, because you are not being given the initial energy level, but you know the final energy level, which is 2. Okay, lambda, so we must be dealing with these 3 formulas. Okay, so we want to find the delta E. Okay, we are given the lambda information, so we should be using this formula. Okay, so that's how you're going to choose which formula you're going to use. So delta E is equal to Hc over lambda. So that would be, sorry, this is for red line. 6.63 times 10 to the power of minus 34 joule second times 3 times 10 to the power of 8 meter per second divided by 656.3 nanometer times with 10 to the power of minus 9 to convert it to become meter. So you are left with the delta E 3.031 times 10 to the power of minus 19 joule. Okay, remember that the question already stated the energy is released, so you need to write negative sign at the front of your final answer. If you don't write the negative, then your final answer is wrong. So you'll try for the green one. Okay, I already gave you the answer. So my answer, I didn't include all the correct, sorry, I didn't write the correct final answer. You should notice it by yourself. Okay. So B, determine transition that produce red, green, and blue lines. Okay, so you're gonna use 1 over lambda equal to RH 1 over N1 square minus 1 over N2 square. Okay, because you knew that N1 must be the ground state, which is 2. Okay, RH is being given already and together with the lambda. So your task is to find N2. Okay, find it for red, green, and blue lines. Okay, C, sketch the energy level diagram. Okay, to show the transition of electron that produce the red, green, and blue lines. Okay, so in your energy level diagram, okay, I remember that this is a Balmer, so and the ground state would start with 2. Okay, you just need to draw it like this. Okay, for example, so just mention which one is red, blue, or green line. Okay, you need to figure this out. Figure this out by yourself. Okay, this is not the correct energy level diagram. Okay, so the last question that I want to discuss is question 8. Okay, so the rest of the question you should finish it off by yourself. Okay, I want to see a complete work of 2.1 when we'll meet next week. Okay, so question 8, a photon with frequency 5.5 times 10 to the power of 15 is emitted when an electron makes a transition from a higher energy level to a lower energy level. So this means that energy is released. So your negative should has a your energy should has a negative sign. Calculate the wavelength of the photon and energy emitted. So delta E emitted by 1 mole of electron for the above transition. Okay. So you are given frequency, you want to find lambda. So the only formula that you can use is V equal to C over lambda. Okay, so rearrange it. So that would be lambda equal to C over V. 3.0 times 10 to the power of 8 meter per second divided by frequency is already in per second, so you can use it straightforward. 5.5 times 10 to the power of 15 per second. So cancel off this second together. So your frequency would be 5.45 times 10 to the power of negative 18 meter. Okay. If the question does not state that you must leave the answer in nanometer, then you can leave it as like this. Alright, so next. Okay, first we need to, in order to calculate the energy emitted by 1 mole of electron, this means that you need to times your energy. How you're gonna find it is by times your delta E with Avogadro constant. So do you have your delta E yet? No. So can you find it? Yes, by using the formula delta E equal to HV. There would be 6.63 times 10 to the power of minus 34 joule second times 5.5 times 10 to the power of 15 per second. So cancel off second with per second. So you've got the energy 3.6465 times 10 to the power of minus 18 joule. Okay, this one is the energy change for 1 electron. Okay, so we want to find the delta E for 1 mole of electron. Okay, so you just need to multiply your delta E with Avogadro constant, which is 6.02 times 10 to the power of 23 per mole. Okay, so the final answer will be 2195.193 kilojoule per mole. Okay, I've already converted the joule to kilojoule. Okay, so make a note that if the question asks you to find the energy emitted by 1 mole of electron, you need to times the delta E with Avogadro constant. So that's how you got the unit of kilojoule or joule per mole. So that's all for, there's more questions. So you should finish it off by yourself.